All right, so here's the pseudocode to implement breadth-first search. It's very similar to what we did for depth-first search, except we actually use a different data structure. Rather than using a stack, we use a queue. But I'm just going to use an array, which we did for the stack, but we just use different methods. Rather than push and pop, we'll use push and then shift, so that we are adding to the end, but removing from the beginning, so that the first thing in is also the first thing out, unlike what we had with the depth first version, where the first thing in had to wait until the very, very end. Okay, so your function should accept a start. We'll just do A. Create a queue, just use an array, just make a variable called queue, and place the starting vertex in it, so there's something to start. Then, just like before, create our result array to store, what we return at the end with our order. Make an object to store the visited nodes, like we've been doing, just call it visited. And then mark the starting vertex as visited. Then the bulk of our logic. As long as there's anything in the queue, just a while loop, while there's something in there, we're going to shift the first vertex from the queue and push it onto the array that stores what we visited, that stores our result. So take the first item out and push it to the result, and then for each neighbor in that vertex, all of its neighbors in the adjacency list, if we haven't visited it yet, mark it as visited, and then add it to that queue. Push it into the end. Okay? So we have our queue. It's the exact same process, well, almost the same process as depth-first search or our depth-first traversal, the iterative version, but we're using a queue instead of a stack. So we're still pushing to the end, but we're now shifting from the beginning. Otherwise, it's pretty much the same. I'm going to write the code again in the next video, but you could just take your code if you wrote it, or take my solution and just slightly tweak it. And at the very end, we do need to return the array of all the nodes we visited. Okay? So make this queue to store everything. Put the first node in there where we're starting out. And then while there's something in that queue, we're going to remove the first item. We're going to add it to our result. Then we're going to look at each of its neighbors. And if they're not visited yet, if they're not marked as visited, mark them as visited, and then push them to the queue and keep going. And then return the entire result at the very end. Okay, so let's do that in the next video.